All right, so we're going to graph quadratic equations today, guys. A quadratic equation is a degree 2 equation. That means the highest exponent on a variable is 2. These are your x squared equations. The graph is going to be a parabola, a U-shaped graph. And remember, I keep saying it has symmetry. And because of that symmetry, I'm only going to make you graph half of it, and then we'll just match the other half. So it'll be less work. But it has symmetry. Okay, if you are a quadratic equation, then you can be written in this form. This is going to be our go-to formula right now. Y equals ax squared. That's what makes it quadratic. The highest exponent on a variable is 2. And then plus bx and plus c. I've been telling you guys every day that if a, the leading coefficient, the number in front of x squared, if he's greater than 0, meaning he's positive, which way will the parabola open? Up or down? Up. We're going up. So you will have a visual as to what it should end up looking like. If a, the number in front of x squared, that leading coefficient, if he's less than 0, then he's a negative number and the parabola will open down. All right. Well, guys, the most important point on your parabola is going to be that vertex, that highest or lowest point. So when you start graphing it, that's where you're going to start. You got to get your vertex. So how do we get the vertex? When they give you the quadratic equation, how do you know who the vertex of its parabola is? Well, guys, lucky for you, there's a formula that we're going to use. The x-coordinate of your parabola will always be equal to the opposite of b. And if you're like, Hardy, who the hell's b? B is always the number in front of x. And then you're going to divide it by 2 times a. And if you're like, well, who the hell's a? A is always the number in front of x squared, that leading coefficient who told us is it opened up or down. Go ahead, down. It's a I always read it as the opposite of b, but yes, it's negative b.
And so it's the same number.
It's negative 1 times b. So it'll be the opposite of whatever the b value is in the equation. Negative 4. And if it was negative 4x, it would be positive 4 would be the opposite. Okay? All right. So your x-coordinate will always be found using that formula. Now, I could show you where that formula came from, but it takes a little heavy-duty math. So I'm going to skip that part, and I hope you will all believe me that every x-coordinate will be the opposite of b over 2a. All right, well, how do we find the y-coordinate of our vertex? Because it is a point. It needs an x and a y. Guys, there's no formula for y. This equation says who y will be equal to. So you're going to have to take whatever number you get for x and plug it in for x to see who y is equal to. So this is where students are like, oh, Hardy, if I have to plug one more number in. There's a lot of plugging in today. So that's where we're going to let the calculator do that heavy lifting for us. But that's how you find y. You're going to plug that x-coordinate into the equation. And then whatever number comes out, that's your y-coordinate. All right, let's do it. Let's try one. All right. I want you guys to graph y equals x squared minus 2x plus 3. So, guys, you can see this ain't no linear equation. This is a quadratic equation, degree 2. So first I want you guys to identify A, B, and C. Who's A in this problem if he's supposed to be the number in front of x squared? 1, beautiful. Who's B if he has to be the number in front of x? Negative 2, don't forget the signs. And then who's C if he's always the constant by himself at the end? 3. All right, will the graph of this parabola open up or down? How do you know it's going up? A is positive, right? So you have a visual. We're going to have a vertex, and then it's going to go up. All right, let's get it. Let's get the vertex. Let's get started. The x-coordinate of your vertex will be equal to the opposite of B divided by 2 times A. So guys, who's the opposite of B if you said B was negative 2? 2, right? Because technically this is a negative times a negative 2 is B, and then it becomes positive 2. Over 2 times who's A? 1. Well guys, who's 2 times 1? 2. So who's 2 divided by 2? 1. The x-coordinate of our vertex is definitely 1. But we need a y-coordinate. So now we're going to take 1 and we're going to plug it in for that x and figure out who y is. This is where I want you to do it just like me. So y will equal, we're going to plug 1 in and we're going to square it. Then we're going to subtract 2 times 1 goes in for x, and then plus 3. Type that into your calculator, hit enter, it will do the entire thing for you. Now guys, that's a subtraction. Don't use the little negative sign for that. That's a subtract 2. It shouldn't matter, but man, do those calculators not like it. All right? Hit enter, and let's see what number you get. It's a really nice number. Right? It's not bad.
You got like $900? Yeah.
It's going to become very, very routine. You'd be on the first day, you're like, oh, forget it, Hardy. This is not. I'm telling you though, it's really not that. And I'm gonna give you a shortcut, so it's okay. All right, what did we get? 2. So now we know the vertex is definitely the point 1, 2. So guys, as you find out information, put it on the graph. Don't wait. Let's graph as we go. So the vertex is right 1 and up 2. Boom. Now I want you to draw the AOS. Let me just warn you. Your homework tonight is on Delta Math. And they're going to make you graph. It will not let you graph the AOS. And I don't like it. I wish it did. I'm a big fan of putting it up there because I really think it helps show the symmetry. So I would like you to, but just know that Delta Math, I don't think it's going to let you because it's really not physically part of its graph. All right. But we have this imaginary vertical line that goes straight through the vertex, cutting it in half, saying that whatever points are on the right side, there's a matching point on the left. Okay, does anybody know what the equation of that AOS is? It is the line, go ahead.
X equals 1.
X equals 1. It should match the x-coordinate of your vertex. All right. The long way to graph these is to use a table. So we're going to do it today, and then like I said, there is a shortcut. So right now, I want you to take your vertex. Why did my table get cut off? Anyway, and I want you to put it in the middle of your table. Always in the middle. Always in the middle of your table. Now what I want you to do is, guys, to create more points. I want 5 total. I want your vertex. I want 2, and then I want 2 more. I want 5 total points, and so does Delta Math. All I ultimately have to do is just plug x's in, create y values and points, and I can graph my parabola. But I'm just warning you, the farther away you get from your vertex and the bigger x gets, you start plugging big numbers in and squaring them, guys, y is going to get huge. So stay close to your vertex. So I want you to pick the 2 x values to the right. So who's the next 2 x values? 2 and 3. And I want you to put them in order. So we're filling the table in 2 and 3. And I want you to pick 2 to the left. So who are the 2 to the left? 0 and negative 1. So 0 and negative 1. I want them to be in order because that really helps to show the symmetry. All right. Technically, you should plug all 4 of these x's in and see what y values they make come out and create points. That's too much work. All you should have to do is plug the 2x values to the right in, and then we can match the points on the left. Or you can plug the 2x values to the left in, and then we'll match the ones on the right. So either you're going to choose to plug in 0 and negative 1, find out their y coordinates, or you're going to choose 2 and 3. Anybody have a strong opinion as to which ones we do? 2 and 3, let's do it. All right. So right now, let's plug 2 in. Start at the vertex and work away from him. So everybody plug 2 in first. So that'll be y equals, we're going to plug 2 in now, just like we did the 1. So now it'll be 2 squared, subtract 2 times 2, and then plus 3. Type that in exactly how I wrote it, and it'll do the whole thing for you. And let's see what number you get. It's a nice number.
Where did you just get this whole equation?
It's always given to you. It's the one they asked you to grab. It is 3, Brendan. All right, so that means that the point 2, 3 is on this graph. So 2, 3. That is a point on this parabola. So guys, look up here. Watch this. See how this point is 1 x value away, 1 jump away from the AOS? Yeah. We'll go 1 x value away on the other side, 1 jump, and match that point. Symmetry. That means if somebody had chosen to plug 0 in for x, guess what? They also would have gotten what y value? 3. It's going to match. There is symmetry on this graph. All right, now let's plug 3 in and see what y coordinate he will make. So now we're going to plug 3 in. Y equals 3 squared, subtract 2 times 3 plus 3. See what number you get now. 6. So now that means the point 3, 6 is on this parabola. So write 3, count from the origin. 1, 2, 3, and then up 6. Boom. Now again, on Delta Math, they won't show the AOS, so you have to count back to where the vertex was. So he is 1, 2 x values away, 2 jumps. So now count 1, 2 x values, 2 jumps away on the other side, and match that point. And now that means, guys, guess what? If somebody had plugged -1 in, guess what y value they would have got? 6 as well. There is symmetry on this graph. And those are the only 5 dots I require. I want the vertex, 2 on the right, and 2 on the left to match. So now you just connect them and give me your best shaped parabola. And you should always show with arrows that he will continue to go up. I could just keep plugging in more x's and creating more points. I know it feels like a laundry list at first, but once you get the routine, you do move through it pretty quick. And we are letting the calculator do a lot of the work. All right, now the silly questions. Does this parabola have a maximum or a minimum point? Minimum. What is that minimum value? What is the lowest y value on the graph? 2. Now I want to know who's the y-intercept. 0, 3, beautiful. Does this parabola have any x-intercepts? None. And the reason it doesn't have any x-intercepts is because his vertex was above and he opened up. It also means that if I tried to solve for the x's that make this equation have a y-coordinate of 0, the answers to that equation are imaginary numbers. They're not real numbers. All right, the domain. Who's the domain always going to be? All real numbers, -infinity to infinity. Because again, I could just keep on plugging x's in all the way to infinity and creating points. And then the range, though. The range is restricted. Who is the lowest y value on the graph? 2, and then all the other y's are what compared to him? Greater than. So y is greater than or equal to 2. So on Delta Math tonight, they're going to make you graph it. You have to click on 5 dots, and then on your 5th dot, the parabola will appear. And then they're going to ask you one, part 2 question. Either they'll ask you for the y-intercept. That's it. Or they'll ask you for the equation of the axis of symmetry. That's it. Or they'll ask you for the roots, zeros, or x-intercepts, however they call them. All right, let's do another one. Because again, the more practice you get, it does become routine. What do you got? All right, now, technically in example 2, they have given you a quadratic function instead of a quadratic equation. But guys, if you're one of those people who's like, Hardy, I hate f of x, then guys, cross them out and put y equals. That's what he represents. He represents the y coordinate, the output of this graph. They are interchangeable. They both mean the same thing. All right, I want to know who A, B, and C are this time. Who's A in front of x squared this time? -1. Who's B? 6, the number in front of X. And then who's C? -8. Will this parabola open up or down? We're going down. A is a negative number. So now you have a visual. There's going to be a vertex, and then everything should go down from there. All right, so we got down. Let's get our vertex. Let's get the graph started. The x-coordinate of your vertex will always be equal to, what's our formula that you have to memorize?
A squared plus B.
No, that's the quadratic equation. What's the formula for the x-coordinate of your vertex? Teeny tiny.
Oh, -B.
Over 2a. I will not be giving you that on any quiz or test. You have to know that formula. So you're not allowed to fall asleep until you've recited it 10 times tonight. All right, what is the opposite of b here?
-6.
-6 over 2 times who's a? -1. Well, guys, who is 2 times -1? -2. So what's -6 divided by -2? 3. You definitely have an x-coordinate of 3. Now you need your y-coordinate, so let's go plug it in and see who we get. So y is equal to, now guys, we've used this before, we've done it before. That square is only on x, and then it's being times by -1. So that -1 in front is not part of who's being squared. So he has to stay outside of the parentheses, because PEMDAS says to square before we multiply. And then we'll plug in 3 and square him. You cannot put that negative inside the parentheses. He's not part of what's being squared. And then we'll do +6 times 3, and then subtract 8. So if I'm you, I'll probably use my little negative sign for that, and then the subtraction symbol for that. Do what you gotta do. Again, it's a very nice number. I strive to be it in all areas of my life. 1, Jake! Talk about number 1. Who doesn't want to be number 1? All right? So now you know you have a vertex at 3, 1. So plot it. Right 3 and up 1. I think you should put your AOS next. So let's put that imaginary vertical line that goes right through our vertex and cuts the parabola in half. I like it for my symmetry. It helps me. Anybody know who the equation of that vertical line is?
Oh, x equals 3.
X equals 3. It should match the x-coordinate of your vertex. All right, we got to get more points. I got to start forming my U-shaped graph. So let's throw our vertex in the middle. And let's pick 2 x values to his right and 2 x values to his left. So if I'm at 3, I have a habit of going right first. Who's to the right? 4 and 5. So in order, there would be 4 and then 5. And then who's to the left? 2 and 1. So in order, 2 and 1. So now in my opinion, you should only have to plug 1 and 2 in, and then you can match them with the 4 and the 5. Or you can plug 4 and 5 in and match them to the 1 and the 2. Does anybody have a preference as to who we plug in? Good, I'm going 1 and 2. But start next to the vertex first. Start with 2. So y will be, now we're going to plug 2 in. So leave the negative on the outside, plug in 2, and square it. +6 times 2, and then subtract 8. Hit enter. It's a wonderful number. Everybody's always afraid of him, but 0. So that means the point 2, 0 is on this parabola. So guys, from the origin, 2 to the right, up or down, 0. Now let's match him. He is 1 x value away from the AOS, so let's go 1 x value away on the other side and match that point. That means if somebody had chosen to plug 4 in, guess what? They would have gotten 0 too. There's symmetry. All right, now we got to plug in 1. Let's plug in 1. So leave the negative on the outside, plug in 1 and square it, +6 times 1, and then subtract 8. Now guys, we're going down, so this should definitely have a negative y coordinate. And what number did you get?
Yeah. I was just guessing.
Good guess. It is negative, a little bit smaller than -1.
-2.
A little bit more,
-3.
-3. So now you get -3. So now we know the point 1, -3. So from the origin, 1 to the right and down 3. That point is 2 x values, 2 jumps from the AOS where the vertex was. So let's go 2 x values, 2 jumps, and let's match it. So that means if somebody had plugged in 5, guess what? They also would have gotten -3 because there's symmetry. Now we connect our dots and we have our parabola. We okay? All right. Now the silly questions. Does this parabola have a maximum point or a minimum point? We got a max. What is the maximum y value? 1. All right, the y-intercept. You're not going to like this. Is the y-intercept a dot that you put on this ring? No. So you're not allowed to leave it blank because the y-intercept is too easy to find. If you are a y-intercept, then who is your x-coordinate?
0.
So you got to plug 0 in and see who he makes come out. You have to plug it in and see who the y-intercept is. So you're going to plug x equals 0 in, and you're going to figure it out. If he's not a dot on your graph, you can find him. But guys, look at this. Look at this. If you plug 0 into standard form, what's 0 squared going to be? 0 times a negative will still be? What's 6 times 0? Guys, they're gone. You're only going to be left with C will be the number you get out every single time you plug in 0. So every time. So technically C, he's your y-intercept, guys. So when x is 0, y will be -8. He will be C.
I just read always.
Always C. Always C. All right, now I want your x-intercepts. Guys, this one actually has how many x-intercepts? 2. What is this ordered pair? 2, 0, and 4, 0. Those are the 2 numbers that will make y equal 0 when x is 2 and when x is 4. They are the zeros. They are the roots of the equation when you set it equal to 0. Go ahead, Brendan.
Oh, no.
All right. The domain is always -infinity to +infinity, all real numbers. The range, though, what y values live on this parabola? Who's the biggest one? And then the rest are all smaller, which would be less. And you're good to go. All right, I want to try and get one more in because they can look a little different, guys. And let me also say this before we do the last example. Guys, do you think every parabola out there has this beautiful whole number, x coordinate, y coordinate, vertex? Yeah. There are filthy parabolas out there. There are ugly parabolas out there. Am I going to assign them at this point? No, there's no need to. All right, but just know, not all parabolas graphs are these beautiful whole number points, okay? All right, last one. All right, the last one. Does he look weird?
Just a little bit.
A little bit. Looks a little tiny, doesn't he?
Yeah.
Guys, remember,
He's missing.
he's missing something, ain't he? Yes, he is. So remember, if you are a quadratic equation, really, the only thing that makes this quadratic, guys, is this term. He's the degree 2. He's the one who has the highest exponent on a variable, and it's 2. That is the reason this is a degree 2 equation. So if you happen to have a quadratic equation that doesn't have a bx term, guess what? It's still quadratic. It's still degree 2. So there might not be a bx term. And if there's no bx term, who's b? 0, because there's no b. There might be a quadratic equation out there that doesn't have a c. That's okay. It's still quadratic. It just means c is 0. And then there could be quadratic equations out there, guys, that don't have bx's or c's. It's just ax squared, and that's fine, because ultimately that's the term that makes this a quadratic equation. So if something's not there, b and c are 0, okay? A can never be 0, because otherwise, if there was no, is he a quadratic? No, he ain't degree 2 anymore. That's actually mx plus b. All right, here we go. So in this problem, we said there's no what? There's no b. So there are no x's in this problem. There's no bx term. So who's a in this problem? 3. B is 0. And c is always the number by himself, -2. All right. Can I just warn you? When a gets bigger, your y values are going to get bigger much, much faster. So it's going to be like a skinny, tall parabola, because the bigger a gets, the crazier the y values get. All right, does this parabola open up or down? We're going up. A is positive. All right, let's get our vertex. The x coordinate will always be equal to, what's our formula? You've got to memorize this. B over 2a. And this is why you might be like, ooh, b is 0? I hate that. No, you're not. You love that. If b is 0, is there such a thing as a positive or negative 0? No. So when they ask for the opposite of b, what's the opposite of 0? 0. Over 2 times a is? 6. Well, 3, it'll become 6, but who cares? Because, guys, what's 0 divided by any number? It's 0. So when b is 0, your x-coordinate is going to end up being 0. So it's easy. And then if you got to plug 0 in, guys, who do we always get out when we plug 0 in?
0.
No. C. And who's C in this problem?
-2.
-2. 3 times 0 squared, subtract 2. You plug 0 in, that's gone. You're left with C. You're left with -2. So now you know your vertex is the point 0, -2. So when B is 0, the x-coordinate of your vertex is 0, and then the y-coordinate of your vertex is C. Which means when you plot your vertex, x is 0, y is -2. Guys, that's directly on the what axis?
Wow.
So your y-intercept is your vertex. So all kinds of crazy questions get answered when b is 0. All right, now let's put our AOS up. Anybody know who the equation of that vertical line is?
X equals 0.
X equals 0. Every single x-coordinate is 0 on that line. All right, now let's put our table together. Let's put our vertex in the middle. 0, -2. We know we are going up from here. Let's pick 2 x's to the right and 2 x's to the left. Well, guys, who's 2 to the right? 1 and 2 in order. And who's 2 to the left? -1 and -2 in order. So now, do you want to plug -1 and -2 in, or do you want to plug +1 and +2 in? I'm with you. Let's plug the positives in. So let's plug in 1 first. Let's start next to our vertex. So if I plug 1 in, plug them in for x. That'll be 3, parenthesis, 1, square it, and then subtract 2. And see what number you get. 3 times 1 squared, subtract 2. Somebody said it. 1. So that means the point 1, 1 is on this graph. So from your origin to the right 1 and up 1. Okay? Now, he is 1 x value away, 1 jump from the AOS. So let's go 1 x value to his left, and let's match that point. So guess what? If somebody had plugged -1 in, they also would have gotten a +1 out. All right, now plug 2 in, and we're almost done. 3 times 2 squared, subtract 2. It's actually off your graph, guys. What number did you get?
10.
10. So now you know the point 2, 10 is on your graph. So from your origin, 2 to the right, and up 10. Sorry, it doesn't fit. So that is two x values away from my AOS where my vertex was. So let's move two x values to his left and match that point. So that means if somebody had plugged -2 in, they also would have gotten 10 to come out. And now you connect your dots and you have this tall, skinny parabola because A is getting bigger. All right, if I was a parabola, this is who I'd want to be. Look how skinny he is. All right, so now we answer the questions. Does this parabola have a maximum or a minimum point? Minimum. Who is that minimum lowest y value? -2. Who is the y-intercept of this parabola? His vertex, 0, -2. All right, we have a problem with the x-intercepts. Guys, how many times does it cross? Twice. But clearly they're not whole numbers. This one crosses somewhere between 0 and 1, and this one crosses somewhere between 0 and -1. Here's my problem. When you don't know the y-intercept, I make you find it, because all you had to do was plug in 0. But guys, if you want to find the x-intercepts, I need you to find the x's that make the y coordinate 0. So I need you to find the x that makes the y coordinate come out 0. You have to solve this equation for x. I have not taught you how to solve a degree 2 equation yet. So I can't ask you to calculate your x-intercepts yet. So all I want you to do is guess at this point. Make a good estimate. If this is a number in between 0 and 1, who could it be? 0.5, 0.6, 0.8. I'll take anything, right? So let's say you said 0.8.
Our club is meeting today.
Well, then probably because of symmetry, this one's probably going to be -0.8.
184 is 167.
And then our domain is normal.
Is
But guys, I need you to know
129.
that those are estimates. Those are really not
Special message from Mrs. Phelps.
the x-intercepts. I just can't make you find them yet. Okay?
Hi everyone, it's your favorite librarian, Miss Phelps. I'm in so many musical. We're throwing brain food at our snack.
Who is this imposter? And then we have y is greater than -2.
to 150 today.
We're
I'm
equal
in
to.
support.
Who is? I've never met. I never met.
I have no idea.
Thank you. Have a great afternoon.